All right, let's take a look at 8.4, day 2 notes, the standard normal distribution. We talked about normal distributions before and with the empirical rule. Now we're going to talk about numbers that don't fall in the empirical rule, that aren't whole number standard deviations away from the mean. So lately we've had 1 or 2 or 0, 1, 2, 3 standard deviations to the left, to the right. They're whole numbers. Well, now they're not. So the standard deviation or z-scores describes how far a data point is from the mean. It's just a number line where 0 is the middle and each tick mark is 1. And of course, we go to the left, it's negative. We go to the right, it's positive. So plate each z-score on the normal curve. Well, negative 1.25, it's past negative 1 or negative 1. So a little bit like that. And that would be negative 1.25. Again, same thing here. 2.34 is between the 2 and the 3, about a third of the way through. And I'll label that just to be thorough. A couple more of these so we get the hang of it and we can picture where everything is. 0.45, not quite halfway to the middle of 0 and 1, but a little bit before it. 0.45. And then lastly, we have negative 2.70. That's way over here. And that's negative 2.70. We just want to label what we're doing so we know what we've done. All right, so now we'll do the same thing, but we're going to shade the area a certain direction. Again, I want to write my numbers here. We don't always have to write them, but once we first start, probably a good idea. Area left of 1.5. So 1.5 is in the middle of 1 and 2. And area to the left is all that. Number 6. We got to label our standard deviations away from the mean. So we have two values here. 1.2 is not quite all the way to 1/2. And it's to the right of that and to the left of negative 2.2. Negative 2.2, that's 1.2. So now we're going to find the area under the curve, which is the probability or the proportion of things that follow that distribution. So first up, finding area to the left. So if we have negative 1.45, that's about here. 49, sorry. And we want area to the left. Well, to find the area, we have to go to our z-score table. The z-scores are on the outside. We have the ones and the tens position going down the left side, and we have the hundreds position going across the top. And we just match that up. So and all of these are the area to the left. All of them. So that's what we're looking for. So we go to negative 1.49. So negative 1.4. And then we have to go to the 0.09 column, which of course is the last number. So we got 0.0681. So the area to the left is 0.0681 or 6.81%. Doesn't really matter how you answer it. Just read the question and make sure you do that. All right, now area to the right, a little bit different. We have to do 1 minus the area on the table because, again, that finds the area to the left. We want the area to the right. Together, they add up to 1. Let's see. There's 2.03. Very little probability or proportion there. Well, 1 minus the area to the left of that, which is, well, we've got to go to our table, a z-score of 2.03. Go to the positive side, 2.0, 0, 0, 1, 0, 2, 0, 3. 0.9788. And again, that's the area to the left. So we have 1 minus that 0.9788, which gives us 0.0212 or 2.12%. So there's not a lot of area to the right of that. And we can tell by looking at it. Finding the area between two z-scores, we find the area to the left of both of them and subtract the larger area, should be the smaller area from the larger area. So we want it between negative 0.93, it's about here. Oops, I don't know where that negative 1 came from. Negative 0.93 and 2.16, which is about here. And we want the area in between. We want all of that. So what we do is we find the area to the left of 216 of 2.16, and we subtract the area to the left of the negative 0.93 z-score. And the difference will be what's shaded in between the two. So again, we look at our z-score table. First, we have 2.16. There's 2.1, 0.10, 0.11, 12, 13, 14, 15, 16. So it's 0.9846. So remember that. Then the other one for negative 0.93, we have to go to the other side of the paper. 0.9, 90, 91, 92, 93. So it's 0.1762. So again, the area to the left of 2.16 was 0.9846. And the area to the left is negative 0.93 z-score would be 0.1762. We subtract the two, and we get 0.8084 or 80.84%. And it looks like there should be a big portion there, and that is probably 80%. Now, the last type that we're going to look at is outside, or yeah, I guess the outside of the two z-scores. So there's actually a couple different ways we can do this. Well, it's probably easiest just to do this way. So negative 1.96, so not quite to the negative 2. And we went to the left of that. And the right of 3.02, which is, well, way over here. There's going to be a very small number there. So we find the area to the left of negative 1.96, and that'll just be the number, plus area to the left of 3.02, but really we want the area to the right, so it'll be 1 minus the area to the left. Now we just got to find those two probabilities on the z-score table, and we got our answers. So a z of negative 1.96, here's negative 1.9, 90, 91, 92, 93, 94, 95, 96, 0.0250. Remember that? Write that down, 0.0250. Then we look at the same paper, but the other side of it for 3.02. So here's 3.02, 00, 01, 02. Not that it makes a difference because all three of those numbers were exactly the same. So 0.9987. but we want the opposite of that. So the area to the left at negative 1.96 was 0.0250, I guess. The area to the left of 3.02, I guess, actually that would be the area to the right, because we're doing 1 minus the area to the left, which we saw was 0.9987. So when we calculate all that, we get a proportion of 0.0263 or 2.63%. And you can tell it's not going to be a large number. There's barely much of anything on the right, and the left, there's not a whole lot either. So that's how we can find area, proportion, using z-scores and our z-score table.